according to the user application. Now, the step needed to design a PCB. If let's suppose I am a beginner and I don't have any experience to design a printed circuit board according to the circuitry, because an engineer is a person who can design any of the PCB or any of the circuit by the basic knowledge and lot of practice in terms of we have to be know about the different components of the electronics industry. Let's suppose if I want to use the resistor, if I want to use the capacitor, it must be clear in my mind that what will be the value of that particular resistor, because the resistor may be having the value of 1k and maybe having the value of 1000. So it depends on the user application that what amount of the what rating of the resistor, capacitor, inductor, or let's suppose many of the electronic component want to use on our circuit. Right? So these are some specific steps. Means we have to follow these steps during the designing process. First, we have to create a schematic. What does my mean by the schematic? The schematic is the circuitry. Let's suppose here I want to connect a AC supply, because any of the circuit demands a type of supply, whether it is AC or the DC. Let's suppose I must connect a resistance over here, then I must connect a capacitor over there, then the output, one coil is there in the parallel. Means this is just for an example, not a proper circuit. So this is the schematic view that have to be known by the user, that what I want to create, what I want to design as a circuit in my application. The second point is create a blank PCB layout. What is a blank PCB layout? First of all, we should create a such type of blank PCB layout with no components mounted over there. Like, let's suppose I want to mount an LED over it. I want to mount an LED over it. This is the symbol. So we have to connect this LED in such a manner the two legs of that LED must be penetrate the surface area of that particular PCB. So at the initial stage, we have to create a blank PCB layout. Third is the schematic capture. The schematic capture is just belonging to the linking to your PCB. What type of schematic circuit we have that must be mounted on the blank PCB. This is the combination of the third point, that is linking to your PCB. Now, designing of your PCB stick up, designing rules and requirements of the user, that for which purpose you want to make your PCB, what are the basic requirements to designing that PCB. Now the place components, at that stage we have to place or added the components on the entire surface of the printed circuit board. Insert the drills or the holes on which we have to create, let's suppose this is my PCB. I have to create 4 holes over 4 side of that PCB, so that we can mount by the help of screws this PCB anywhere at the top of any circuit, at the top of any surface. We can mount with the help of these holes with the help of screws. Now route traces. Route traces is the process that very important in the designing of PCB, because during the routing we have to connect the proper wiring or the connection of the different components mounted on the PCB. Add labels and identifiers. Finally generate the Gerber files or the designing files. By the help of these files, we can design the final hardware circuit. Now, what are the advantages of PCB? Because the question arises, when wired connections are there, when all prerequisites are there, then what is the need to design a PCB? In the first point, it is very clearly mentioned that printed circuit boards find in compact size. Compact means very small size they have. In fact, if you want to design a PCB of 10 by 10 mm, 5 by 5 mm, you can. It depends on the requirements that how many number of components you want to mount over a PCB. So this is a very easy for the transformation because it is very small in the size. This is very compact in the size. So the transformation is quite easy comparatively to the complex circuits. Now, the second point, there are very few chances of connected components getting disconnected in the PCBs than a conventional wiring. As you can see in your houses, if you are connecting two wires without a plug-in socket into the direct board, so they'll get disconnected very easily. If you are having two wires connected in a socket with the help of a plug or a switch, that time the connection are much more strong comparatively. This is same which is happening in the case of PCBs. If I'm a user and I am doing the conventional wiring for my circuit, that time there are lot of chances to get disconnected these wires. And if I'm going to design a PCB, the chances are very, very, very less. In fact, 0.1% to get disconnected the components because there are no wires externally connected over out the PCB. So PCB designing and fabrication takes a less time than making the wire connection, because in the wired connection, we have to keep in our mind at each and every node or each and every point that this R1 must be connected that LED with the help of R2 with the help of capacitor. But in case of printed circuit designing or in case of PCB designing, if I put my component over the surface of PCB and create it as the Gerber file, so there are very less chances or the very less probability to making the connections wrong. Now, the next point is the electric component are fixed in a PCB through the soldering. We all are engineers and very much aware by the term of soldering. Soldering is the process by which we can fix any of the component over the surface of PCB. When I'm fixing any of my component over the surface of PCB, that time I must understand this thing. The component is fixed for long term, not for the short term. If I connect that component with the help of jumper wire, so that is having very less life rather than or comparable of soldering. So it is easy to simplify components over the PCB. The next point, the less wiring is required for the PCB designing. Yes, this is very important because in the PCB circuit designing, the number of wires are approximately negligible in case of PCB. But if I considered or I go with the wired connection or the conventional wiring, I must use a number of jumper wires in the single and very simple circuit. That makes the circuit very much complex. The PCB gives the good flexibility to place the requirement or the components and fix them at a specific position. By the help of this, we can fix each and every component on a very appropriate position. So, this board is a very economical than the PCBA due to the less requirements of PCB wiring and the components. It creates the less electronic noise because in the conventional wiring system, I'm tuck in and plug out the connection more and more numbers. So these are very noisy, they are having very noisy outputs. Means number of harmonics are there in the output. But in this case, we are having very less noise. The troubleshooting, inspection, and the replacement of the faculty components or the connections on the PCB is very easy over a regular wiring. We know that under the short circuit fault conditions, the failure of component PCB can be easily checked through the help of multimeter. If I am having a PCB, entire PCB with me, that is quite easy to check whether my component is working properly or not. Because in the conventional wiring, we have to know or we have to understand the proper detailed checking of the circuit, and because of the jumper wires, it is quite tough to check each and every component at every step of the output. But in case of PCB, it is quite easy to manage the output. We can carry the PCB board very easily in the market at very affordable cost. Having lots of advantages, some cons are there of the PCBs. We should know that while we are taking consideration of the PCB designing, once you print the circuit on the PCB board, you cannot modify it. This is the major disadvantage of the PCB designing. In the conventional wiring, if I'm having a circuit and thinking about to changing my connections or components, it is quite easy to manage in the conventional wiring. But once if I designed a PCB, it is quite tough or impossible, near to impossible, without desolder of that particular component to make it modify. The soldering is a requirement to connect or fix the electronic component on the PCB. As I told you earlier, the soldering is the process by the help of soldering we can fix or mount any of the electronic component on the PCB. Now the third point, again for the soldering, thermal shock is required. For the soldering process, the thermal shock is required. PCBs contain more amount of lead. The etching process is very harmful, which is required to manufacturing the PCBs. In the designing of PCBs, it is very compulsory or mandatory to design to follow the steps of etching. That is not too easy to follow, because the steps have to be followed in the process of etching is quite harmful. This circuit can be used only for the specific function and the feature of devices or the systems. These are few of the limitations, or we can say the cons or disadvantages of the PCBs compared to the conventional wiring. Now, as I told you in the content list or my index list, that there are many of tools or open sources are available on the Google. Few of them is listed in my presentation. We have to check it or follow it. Like first tool is the Autodesk Eagle. If I want to create my own PCB with the open source software or by the help of the Autodesk Eagle, the Eagle is arguably one of the most well-known schematic and PCB designing software. Usually and formally we can pronounce it that the cats of eagle, but nowadays its name is modified like Autodesk Eagle after its purchase from the Autodesk. Might be you don't aware about that. Nowadays it is taken over by the Autodesk, so that the name of the product is modified like as Autodesk Eagle. Autodesk Eagle contains a schematic editor, means as we can already see in the designing steps, first we have to create a schematic view of my layout. So that for the designing circuit diagrams and a PCB layout or editor for a designing PCB. It provides component placement, PCB routing, and the comprehensive library content are a thriving community, and many more. A free version of the Autodesk Eagle is available that can be downloaded with the eaglefree.eagle is now only available with the fusion of 360 subscriptions. This is the limitation of that software. So generally we are not using it as open source. It includes 2 schematic sheets, 2 signal layers, and 80 centimeter square broad area, or we can say the workspace area. Eagle is available for Windows, Linux, and the MacBook. This is the basic introduction of Autodesk. If I designed a PCB with the help of the software Autodesk Eagle, so let me show you this type of view I'm having at my screen. Here the file, edit, open, view, router, library, many options are there at the uppermost window. This is the schematic view of my PCB, whatever I want to design during this. And this is the layout of that particular PCB. So this type of schematic view I'll be having with the help of Autodesk Eagle. Because the limitation of the time of presentation, we can't describe or we can't explain all of these 10-15 tools. So we'll be following one or two open source tool at the next half. So the second tool and very important and very famous tool is the KiCad tool. KiCad is a cross-platform and the open source electronics design automation suite. It includes a schematic editor that is very important in each and every PCB design open source software. If I'm using any of the software for PCB designing, it must be having the schematic editor, because without having this section, we can't edit our layout of the circuit. For creating and editing a schematic design, a PCB editor for making the professional PCB layouts with up to 32 copper layers and a 3D viewer. What does that mean by this 3D viewer? 3D viewer is the final layout of the designed PCB in that particular software, by which we can recognize or we can see that after the final hardware designing, what type of view of a PCB will we have with us. So we can see this at the starting by the help of 3D viewer. Now, which can be used to inspect the design in 3D form, unlike Eagle. In the previous software, Eagle, this facility is not available there. In KiCad, is entirely free and no payable is needed to the use of its features. KiCad is also available on the Windows, Linux, and MacBooks. The schematic view of the KiCad looks like that. If I'm having the layout or the pin diagram of that particular system, that is the UX Max 2837, and these are the different type of components over here. This is the transformer. Here we are using a conductor and capacitor of 22 picofarad. A capacitor is here, an inductor is here of 6.2 nano Henry. So this is the schematic view of KiCad tool. Now the next tool is the fritzing. Fritzing is the tool just like KiCad and fritzing, just like KiCad. This is also an open source platform and it is very easy to use for learning electronics. If you are a beginner for PCB designing, if or you want to go on in the VLSI designing, you can use this tool. That is quite easy and having their own help window also. So, fritzing became popular with its example of Arduino, and it's an easy to use and perform. Nowadays, if anyone wants to create any circuit using Arduino, they are mostly downloading the free softwares or open source software like fritzing. This fritzing includes a broadband layout, schematic, and PCB view for the designing of a PCB layout for your board. With a rich interface and the growing community, we want to be a successful application based output of that particular circuit. The software is available for the Windows, Linux, and Mac. Each and every tool is supports a particular type of operating system. Like some of them are Ubuntu, some of them are Windows, some of them are related to the Linux. So you have to check before downloading it whether your system is supportable for that particular or not. The schematic view of fritzing is like that. If we want to design a perfect PCB with the help of the fritzing, we'll have a connection of like that. It is quite easy. If I want to pick a register, I just want to pick from here and want to put over there. If I just want to pick a transistor from here, so I can connect it wherever I want to. Next, the next tool is the Designing Spark PCB tool. With an arguable easy to learn environment with a schematic capture and a PCB layout tool, Designing Spark PCB is one of the EDA tool to try out. What is this EDA? EDA refers to electronic design automation. So if I want to design any EDA tool with the help of this Designing Spark, we can. It is free, comes with an excellent schematic capture, PCB editor also inbuilt in this software. For designing an unlimited number of PCB layers, we can use with the help of the software. A part of library, creator, 3D views, and many more features are there in this particular software. I have listed approximately 8 to 10 tools in my presentation, and many more are available on the Google. Designing Spark PCB is only available for the Windows. This is the main drawback, or we can say the limitation of the Designing Spark tool, that this tool is support only on the Windows. This is the schematic view of the Designing Spark PCB. We can see here the designing structure seems quite easy. Here, the normal functions are there at the upper window, like File, Edit, View, 3D, Add, Settings, or Output tools are here. If we want to place any type of component, but it is mandatory, or we can say that it is compulsory before going to design any of the circuit. We must know the basic of the components or the designing circuits. The next tool is the Easy EDA tool that we'll discuss practically in the upcoming session. Easy EDA is a free and a paid. This tool is having two versions. One is free for the basic trial for the 14 to 30 days, and second is the PDA tool. If we want to use it in the conventional way, we have to purchase a paid EDA tool. Easy EDA provides a powerful schematic capture, PCB editor, libraries, designer, a project management tool, and lastly, a team collaborator is there. Easy EDA also has an integration with LCSC.com component catalog for providing the real-time stocks and pricing. Let's suppose if I want to design my PCB with the help of Easy EDA, at in the last of the designing, I have to be download the Gerber file and want to make it at hardware. Easy EDA is an online based and also desktop based. It depends whatever user want to use. It is having its both options. So it cross the platform and support Windows, Linux and MacBook. This is a schematic view of Easy EDA. Here we can see it seems quite easy. Some components are listed here in the left side window that is highlighted in the red color by me. If I want to use this capacitor, if I want to use this resistor, we can use it easily with the help of this window. I just pick this and place in my workplace area. Now the next tool is the TinyCAD tool. TinyCAD tool is a simple and the basic electronic circuit schematic and PCB designer tool. It is also an open source software project. It supports standard and custom symbol libraries. It supports PCBs, layout programs with the several netlist formats and can also produce a spices simulation netlist. The TinyCAD is only available with the Windows version. Out of the approximately 10 tools, only 2 tools are there which are only supports the Windows version, if you noted it. Now, this is the schematic view of the TinyCAD. We can see here the number of library functions are there in the left side window. If you want to put out any of the component with the proper specification, you can put in the workplace area and easily connect with the different nodes over an entire system. So here my presentation part had done. Now I'll share my real-time window. Just give me a second. I'll share my real-time window with you for the practical implementation of the PCB designing. Just give me a second. Hopefully my screen is visible. My Google screen is visible to everyone. Please write in the chat box because
Yes, ma'am, it's visible.
yeah, thank you so much. Now, if practically I want just 1 minute, I just want to show you the practical PCB so that you can understand. Hopefully, this PCB is visible to everyone. We have to design this type of system. This is a copper based system and different components are mounted. Here you can see no jumper wires are there for connections. So we want to design such type of PCB with help of our open source system. Yeah. Is my screen visible on that Google window is there? Is it or not?
Yes, ma'am.
Yeah. Please, if I want to work without downloading any of the software, you just type jlcpcb.com. jlcpcb.com. I'm writing in the chat box also. J, jlcpcb.com. Yes. When you are entering this tab, you will get such type of pop-up on your screen. Is my pop-up of JLC PCB is visible to everyone? Please write in the chat box whether my pop-up is visible to everyone of JLC PCB. Okay. Now, here in the rightmost corner, you are able to see one option that is of sign in. If you are a previous user or you are an old user of that particular software, so you may sign in or if you are a new customer or new user for that particular, you must be click on the new customer. When you'll be click on that, you'll have a window that demands for a new account. You must be type your username over here. Let's suppose Payal. My email ID is here. My password is there. And I must click on the confirm of the robot, then sign up. I'm not doing this because I'm already a user of that particular software. So I'll be logging with my previous account. I must click on the sign in. When I am clicking on this sign in, this demands a username or the email ID. That is Dr. Payal. My password, I'm typing my password over here. Now, I must take in this particular chat box of I am not a robot, then sign in. When I'm clicking on the sign in the rightmost corner, you can see that Dr. Payal, my username is visible here. I am logged in with the name of Dr. Payal. Is it okay? Are you able to see this? When I'm just putting my cursor on my username, I'm having many of the options on my screen like order history, file manager, messages, coupons, and sign out. Just click on that order history. That order history must be show your previous history of different orders, different projects that you have done in your past. Yes. Now such type of window you will have on your screen. JCB PCB, this is the window. Now I'm just dragging drop and down this window with the help of this. In this network sites, you are having an option that easy EDA over here. I just click on this easy EDA. I'm already switched into the easy EDA because I'm already having my account in that particular JLC PCB software. When you will be registered yourself in that particular software, you will automatically switch into the easy EDA design software, that is the PCB design software. Fine. When I'm having this window with my on my screen, I just click on the easy EDA designer. I just click on this easy EDA designer. Now the screen will opening. This is my workplace area where I can design any type of project, any type of PCB, any type of circuit with help of this software. Because I'm going to design a new project, just click on that file, new project. I'm having this. Uh, I just want to give some name of my project, that uh, basic project. Fine. We can change the path also. If you don't want, that is not mandatory. This is already considered, that software already considered a defined path according to your system. Now save. When I clicked on the save, my workspace will be open on my computer, on my screen. Fine. Are you able to see? Hopefully. Now, this is the particular work area where I should mount my components, finally simulate them, my 3D view, my Gerber files, all have to be done over here. Fine. In the left side, if you are able to see, many options are there. First is the design manager. Second one is the commonly library. Third one is the library, LCCC path, JLC PCB, and supports. Many options are there in the left side. So when I'm clicking on the common library, if you are able to see, yes, I think it is more clear now. When I clicked on the common library, then many of the electronic components they are already having with the software's library are showing me like ground, VCC, register, different type of register, variable registers, capacitors. Hopefully it is visible to everyone. Different type of connectors are there, different type of transistors are there, LEDs, diode, BJTs, relays. Means component whatever you want to use must be included in the library. Let's suppose you want to use any type of component that library doesn't have, so you just click on the library, we'll do that, or just type whatever you want to use. Fine. Let's start with the practical implementation. So, before starting, we have to decide or we have to clear in our mind that what circuit you want to design. Fine. We'll start with a very basic circuit, that is AC to DC converter. AC to DC converter. If I want to design a very basic circuit, that AC to DC converter, you know very well, this is the rectifier circuit. For that, we have to need the connectors, diodes, rectifiers, registers, means different type of components we have to require over here. Fine. So let's pick and do the prepare the circuit. Fine. First of all, I need the connectors. Let's scroll down this and search where is the connector. Fine. Here, the different connectors. Are you able to see on the screen's left side corner? Connector is here and different type of connectors, 1 port, 2 port, 4 port, 4 port, 6 port. It depends on the user application that what type of connector you want to use according to your requirement. Fine. When you just click on this arrow, you'll get some particular specifications also. Let's suppose you want to use 2 pin, 3 pin, 3 pin, 4 pin. It depends on the requirements. Fine. When I click on this, let's suppose I just want to pick this. Yes, this is my connector. I just want to take it. One connector is here. I want to use 2 connectors in my entire circuit. So one connector is here. If you are using this software with me, you'll be find a difficulty that When you are dragging the component from the library to the workplace, the line will not disappear. You just click once right to disappear that particular line. If you want to, yes, just a minute. Yes, this is the zoom view. Means I have connected two connectors over there. Uh, yes, we can easily drag and drop anywhere in the entire workplace. Fine. Next, as I told you, I want to design a AC to DC converter. So I needed a bridge rectifier or the setup of diodes, which is more comfortable to me. I have to select. So in this library, as I can see, there is no bridge rectifier is there, connected with bridge rectifier. Some individual diodes are there, but the circuit will be get complex if I'm using four diodes and further will connect with a single wire. So that is quite easy. Rather than the four diodes, I'll be pick only one bridge rectifier over out the system. Fine. Now I just click on this library. When I clicked out this library and typed whatever I want to bridge rectifier, fine, just entered. Different type with different of specification you can see over here on my screen. When I typed the bridge rectifier, all type of bridge rectifier with different specifications, we can see a number of list of bridge rectifiers are there in the internal library. Fine. It depends whatever you want to use for your specific purpose. When you will be click on that individual component, a schematic view with the symbol on the rightmost side will be appearing. Fine. Like if I want to use this, the schematic view and the system will be appear this side. So I just want to use this type of bridge rectifier. In that, four connections are there. Two is for AC and two is for the other rest plus or minus supply. Just tick on the place. Yeah. Now I place the bridge rectifier on my workplace area. Fine. We know that a transformer is also required. We know that a transformer is also required to design the system, because if I want to convert the 220 volt AC into the 12 volt AC, I must use the step down transformer in my circuit to down the voltage of that coming AC. Fine. Now, I required a capacitor of 1000 microfarad over there. I think here it is the capacitor, but the specifications are not specified over here. So I just go again in the library and type capacitor 1000 microfarad and just enter. When I entered for this, different type of capacitors are there. When I click on the individual type of capacitor, I'll be having such type of circuit with it. Fine. So it depends what type of capacitor you want to use in your circuit. It depends on that. Fine. My requirement is of such type of 1000 microfarad circuit, that is of 16 volt. I'll be yes, this is the 16 volt circuit. Fine. Now place this over here. Fine. These are the four components selected by me to design in PCB. After that, the voltage regulator IC is needed. It depends ki what value you want to use as a voltage regulator. This is the window of voltage regulator ICs. Like you can use the 7812. Just click on that. Different type of specifications are here, like 7805, 7805 7809, 7812. It depends what you want to use according to your system. Fine. I want to use this. This is my voltage regulator IC. I just placed it out. Fine. Now I need a resistance also, because a resistance is very much necessary component over the at the end of the output, because if the extra amount of current will be flowing through the circuit will be getting damaged. So we have to select a resistance and put it over here. Fine. Now whether I want to connect a LED in my circuit, that is not compulsory, but I want to connected a LED in my circuit to make the output visible. If the LED will glow, I'll ensure that my output is coming. If my LED is not in the glowing mode, I'm little bit I have to be check my circuit at every node that where is the faulty part. Fine. So I must select a LED from the circuit component. Yeah, here is the LED. Different colors LEDs are available in the library, like LED red, LED green, blue, with the different specifications also, with the different three layers also, like 3 mm, 5 mm. Yes, I want to use it 3 mm LED in the red color. Fine. I just put it over here. So all my required components I have to select from the library section or the common library. Fine. We can easily rotate if I, yes, if it is needed or required, I can rotate my components. Like I just click on this register, and here is the option rotate right. Now my resistance is in the vertical mode. Similarly, if I want to make my LED in the vertical mode or in the rightmost direction, I just want to rotate it with the angle of 90 degree. Fine. These are the basic components. Now I must connect these components according to the circuit requirement with the help of wires. So here wiring tools are here in this window. I just select a wire from here. Fine. You can see easily on my screen that when I am dragging this wire on my workplace area, red dotted lines are visible on my window. Fine. When I just want to connect this, what I'm having, I in this regulator, in this bridge rectifier, pin number 1 and pin number 3 are representing the AC, and pin number 2 is for the plus terminal and pin number 4 is for the minus terminal. Fine. So I just want to connect this over here. Yes. Yes. When I'm dragging my cursor from one place to another, a green line that shows the wire connected between pin number 1 to the pin number 1 of the bridge rectifier. Fine. If you want to turn or terminate your wire from any end, you just click once over there, then then your wire will get terminated from there. Again, you have to select the wire from pin number 2. Pin number 2 must be connected with the pin number 3, because this is the workplace area. Yes, two connections are done. Fine. I must connect this capacitor in the right mode fashion. Fine. Yes. Now this pin number 2 having the positive polarity must be connected with the positive polarity of the capacitor. Like Yes, this has to be done like that. Now, my negative terminal of the capacitor must be connected with the negative terminal of this bridge rectifier. In the same fashion, I have to use a connecting wire from here. Yes, this circuit has to be approximately completed. Here is a problem in the practical implementation. If you click twice over there, then the circuit will get showing error, probably. Fine. Now, the voltage regulator IC. Pin number 3 of that voltage regulator IC, this is the input. So, it must be connected with the input side. Fine. And this output terminal must be connected with the resistance. And this middle one is the connected with the ground. I must connect this resistance with the positive terminal of that LED. So the output of this terminal, pin number 6 or pin number 2, must be connected with the resistance. Fine. And the negative terminal of that LED must be connected with the ground. Fine. Now one connector is here. So the next connection means we can connect with the wire. Let this must be connected with the help of this wire to the system. And again selecting the jumper wire tool and connecting this with the help of this. Now my circuit, average circuit is almost complete. No connections are remaining for further. This is my basic circuit in which I have to convert the AC into 12 volt DC output. First, I have to save my basic design by clicking this icon, second number icon, that is having a save option. Now my design is saved successfully and with the name of basic project. Fine. Now the next step is when I'm going to design this, my main work is I have to go in the designing. In the upper bar, you are able to see one option, design is there. By the help of this option, I just convert my schematic diagram into the PCB. When I clicked on this, check nets, there are some unfinished nets. Do you want to check the net first? Yes. If any connection is missing or not in the proper manner, this pop-up window will show on your screen. If I just want to check my connection, yes, I want to check it out. I know that this is not the proper connection. I want to make it again. Now this is a proper connection. Again, I have to save my design. Now my design is saved successfully. Go to the design, convert the schematic view. Keep going. Now my basic schematic design is getting converted into the basic PCB design. Are you able to see my screen? Are you able to see my screen? A pop-up is there of a new PCB. In that a unit must be there. We can change the unit according to our requirement. A copper layer, how many number of copper layer you are needed, 2, 4, multi-layer, board outline, you want to make it circular, you want to make it regular, the size of your PCB, you want to change your dimensions or the type of the PCB from this window, from the help of this window. Now I just click on the apply. So with the basic parameters or basic dimension, I'm having this size of the PCB over here, and this is my schematic view that I had already designed. Okay, I just want to place my component inside it so that I can arrange these schematic components into the final full form of the PCB. Fine. First of all, I just drag this bridge rectifier over here. Fine. Now this is my connector P1. I just want to rotate it at the rightmost. Yes. This is my connector second. Also want to rotate it right to make the connections comfortable. Fine. Now the LED is there. Now the LED is there. Rectangular IC. LED is here. Actually, we have to place the component in such a manner it will having a less size. Fine. Capacitor over here and the I is here. Right. Fine. These all are the types of components are connected here. We can see here all type of connections. Too many space is in the between of capacitor and the connector. We can drag it a little bit closer, and we can also view the size of this particular. Fine. I just want to settle these all components in a proper measurable area to make my PCB goes. Fine. When I design this, or when I rearrange all the components according to my requirements, now just save it again. Fine. Till this step, we have to follow the previous designing steps or methodology of PCB designing. But from now onwards, we have to make the connections because the connections are very important. We can make the connections manually according to the requirement of the circuit with the help of jumper wires. But an easy way is also available. We just go on the route and the auto route is there. Such type of pop-up window will be showing on my screen that is showing like general options, routers available, designing rules. They are all by default set. We just run this. When we clicked on the run, the routing is getting started. From 0%, my circuit will get routed slowly. In the process of that routing, all connections have made done correctly by the software itself. Means there is no need to connect any connection in a proper way by the help of jumper wires. I think some slow speed of internet routing process is taking time. I'm doing it again. Just go on the route. Auto route is there due to limit. Okay. A pop-up is showing an error due to the limitation of the router server resources. Multiple routers executing concurrently are not supported. Please try again later or it manually. Fine. So if the connections are proper according to your system, then it is showing okay. And if is there any error occur in your system, it will be showing the system. Fine. Again, I'm trying auto route and run. We'll wait for a few minutes. Might be possible it will get route. When the routing process is there, it is having some, actually this is an online source, so many of the concurrent auto routing is in the queue, so that the software will take time. I'll show you my another project with the help of this designing route tools help. Yes, the next step of this PCB designing, after this routing completed, I have to I want to see the 3D view of my all components. Let's suppose I just want to see this. I just click on the 3D view. When I'm getting connected with this is the 3D view of my designed PCB. You can see easily here that this is the bridge rectifier, this is the LED that you have selected, this is the resistance, these two pins are there, two connectors are there, P1 and P2. We can rename it like uh, AC, one connector is there for the AC and second one connector is there for the DC. This is the capacitor you have selected. Fine, this is our basic project. Fine. Now we have to rename it that P1. This is the AC 12 volt. Now you can see AC 12 volt. When I require 12 volt AC, that time I have to, yes, this is, we can rename all the components according to the requirement. This is my DC. So here you can see this is showing by the name of DC again. Okay, this is just for the router purpose, AC 12 volt. Yes, in the libraries it is updated. Fine. If I just want to check out the 3D view of my entire PCB, I can see here like I rotate my PCB at the angle of 180 degree. Fine. Now I can see, yes, these are the downward lags of these components. If you used any electronic component earlier, you can easily understand if I'm using a diode, if I'm using an LED, that time 2 or 3 lags are penetrate that particular copper window. This size of this copper layer is 3 mm, which I had selected from the library at the time of designing tool. But you can see here at the downmost layer and the upmost layer, there is no jumper wire is showing at the entire circuit. Okay, this is the very basic circuit. You can see register is showing with the name of R1, LED is showing with the name of LED. Means you can rename your all components according to your area, according to your requirements, whatever you want to keep it in your mind. Fine. Now the final step is, if my design is final from all aspects at all criteria, it is perfectly okay, then I just want to make it as hardware. What I have to done for make it as hardware, I just want to make its Gerber file. Gerber file is the type of file which I should send to the hardware designer to make it as hardware. Fine. For that purpose, we have to click in that file, generate file source. Click on that file. This is second last option, generate PCB fabrication. Bracket mein you are able to see Gerber is there. Means this is a Gerber file. Please save your file before the operation. Means first we have to save our file again for the yes. Now again we can generate the Gerber file. Yes. This is the exact Gerber file that we have to send any of the hardware designer who can design the hardware and that particular PCB. So with this tutorial, I think it is very clear to all of you that for the basic designing of any of the circuit, this is very basic practical I have shared with you. If you want to design any of the complex circuit with the help of this, you can easily go ahead with, because each component is available in the library or the common library. If you don't find any of the component in the common library, you just click on the library and type the name of that particular uh, product or component that you want to use in your circuit. Fine. Up if just I just want to click this one click order. Now Gerber view. This is the Gerber view of my entire surface. Fine. So that is done from my side. If you have any query regarding any component, regarding any design, any of the software tool, you may ask. Is any participants, please, if you have any doubt, any query, you may unmute yourself.
Hello, ma'am.
Yes, Mr. Sachin Chawla is there, I think.
Yeah, ma'am.
Yes.
Ma'am, I was unable to generate go for the press auto routing. It was showing the same error at my side.
Actually, when we are doing connections with a green wire, sir, if your node is double clicked at the same place, na, that time it will showing error. You just click on that particular wire where you have doubt and remove it by the delete tab and again reconnect it.
Okay, no, I was facing the error when it was going to for auto routing process.
Auto routing, that is I am saying, sir, when we are connecting the green wires in the PCB workplace area, na,
Yeah.
if we had clicked by mistake twice at the same node, it will showing error.
Okay, okay, okay.
Uh, if you want to change your any of the connection, you just click on that particular node and delete that particular connection by the delete tab and reconnect it when you will get the proper connection.
Okay, ma'am. Thank you.
Any of my fellow colleagues, please, if you have any doubt, any queries regarding any of the basic, because this is very basic session regarding the PCB design. If if you have further, if you have any doubt and query, you may contact me anytime. No issues. Huh? I think it's done from all of you and my side too. At the 2:30 sharp, we'll post assignment in the Google Classroom. As you all know that 80% attendance and daily basis assignments are very much compulsory to get the certificate. Please be aware about that. Na? Thank you so much.